Now let's look at a couple of inequalities involving polynomials that will be application problems. First, example 4, a car's stopping distance in feet traveling at x miles per hour is modeled by f of x equals 0.0875 x squared minus 0.4x plus 66.6. Okay, where this kind of function would come from is you would take some data for different speeds and the stopping distance required for the car, and you could fit an equation that matches those data points. Okay, question A, what is the stopping distance for traveling at 65 miles per hour? So if we carefully read what's in the question, we're asked what the stopping distance is, that's f of x, and we're given 65 miles per hour, and it says in example 4, that's x. So for question A, all we need to do is put 65 in to our function. And then use our calculator to go ahead and calculate what the value of the function is when x is 65. So if you punch this into your calculator, you should get 410.2875. Okay, so let's go ahead and round that to 410.29. So it would take about 410.29 feet to stop if you were traveling 65 miles per hour. So that's longer than a football field. Question B, what speeds require a stopping distance of more than 500 feet? Okay, so what speeds require a stopping distance of more than 500 feet? Okay, so in this problem, we're asked for a speed, x, okay, and we're giving a stopping distance, which is f of x. Okay, so we're going to find all of the speeds that require a stopping distance more than 500 feet. Okay, more than is an inequality word. So it's saying take your stopping distance, which is represented by our equation, and find when this is more than, or in other words, greater than 500. Okay, so this is a polynomial inequality, and we can solve this just like we have solved other polynomial inequalities. First thing would be to subtract 500 on both sides to get 0 on the right-hand side. Okay, if you subtract 66.6 from 500, you'll get 433.4. And we're figuring out now when is that greater than 0. Okay, so we can solve this like we did the other problems. Let's go ahead and graph. So on your calculator, you'll want to type in y equals 0.0875 x squared minus 0.4x minus 433.4. When you graph, you're not going to see very much because the values in this problem are quite large. Okay, so let's start working on a window. First off, if I hit window, we're going to use some of the knowledge about this problem to decide what our window should be. First off, x min. X represents speed. We don't need to worry about negative speeds because you won't be driving backwards fast enough to have a stopping distance more than 500 feet. So let's set our x minimum to be 0. In part A, we saw 65 miles per hour was 410 feet. So we certainly want to be past 65 miles per hour to find 500 feet. So let's say for x max, let's make that 100 miles per hour. Okay, and let's graph and see what our graph looks like. Okay, so you can't see too much of the graph, but we can see right here we have an x-intercept, and here we're above, and here we're below. So let's go ahead and find that x-intercept if we can. We may have to adjust our y window, but let's go ahead and try. So second, calculate a 0. Right now I'm at x equals 50, that's right in the middle. My graph is more like 70 or 75. So we need to move to the right. Just hold your right arrow down until you can hopefully start seeing that cursor. Okay, so there's my cursor at about 72.3. So I want a left bound, okay? Left bound on this one is going to be to the right, okay? So left bound right here at 72.3, and right bound is going to jump up here. Okay, and we get 72.70. Okay, so if you look at your graph, if you hit trace, you can see this a little bit better. 72.3 is negative, 71 is negative, 70 is negative. So less than 72.7 is negative. If you trace to the right and get up to like 73, you're at positive 8.7. 74.4 is y equals 22. So if you're greater than 72.7, your graph is positive. Looking at my inequality, we were solving when it's greater than 0, and so that would be for speeds greater than 72.7. So any speed greater than 72.7 in this car would require a stopping distance more than 500 feet. Example 5, another application, says the position of an object in free fall thrown upwards from the top of a 190-foot tower with an initial speed of 96 feet per second is given by s of t equals negative 16t squared plus 96t plus 190. During what time period will the height of the ball exceed the height of the tower? So if you think about what's happening in this problem, you've got a 190-foot tower, and you are going to throw a ball upward, and it's going to come back down. And so you want to figure out what part, this part right here, how long is that above the tower? Okay, so starting from time equals 0, we need to figure out how long the time goes until the ball is right here. Okay, so this is another inequality. If we're looking at a height exceeding another height, we'd have the height of the ball, negative 16t squared, plus 96t plus 190. And the problem says we want that to exceed the height of the tower. So be greater than the height of the tower, which is 190. Okay, so solving this, we'd want to first subtract 190 on both sides. 190 minus 190 will be 0, so we can omit it, is greater than 0. Okay. Graphing. Y equals, we want to graph negative 16, you can just use x squared, plus 96x. And let's adjust our window. Okay, for x min and x max, we don't want to have negative time. X max, if you've ever thrown anything, you'll know that things don't stay in the air for very long, even if you throw them off the top of a building. So x max, 10 is probably sufficient. And let's go ahead and press graph. Okay, and so there's my graph. You can see double pixels right here, so it's going up and then coming back down. So let's find out this x-intercept right here. Second, calculate. Number 2 is 0. X equals 5 is right here, so we want to move to the right a little bit. To about 5.95. That'll be our left bound. And right bound, about 6.06. Okay, press enter, and we get x equals 6. All right. To the left of 6, if you press trace, If we trace to the left of 6, 5.95, we're positive. If you trace further left, 5.85, still positive. So left of 6, we're positive. And trace to the right of 6, negative 6, negative 16, so negative when you're to the right of 6. Looking at our inequality, we want to be greater than 0, and so that would be up to 6. And again, time equals 0 is when we start, and so this would be for times between 0 and 6.